Welcome. My name is Whitney Lee. I'm a developer advocate, and I'm here with Ed. Ed, will you introduce yourself, please?
Absolutely. My name is Ed Warnicke. I'm a distinguished engineer at Cisco Systems and one of the co-founders of Network Service Mesh.
Awesome. Network Service Mesh. Those are the magic words. That's why we're here today. So Ed and I just had a 2-hour-long conversation about Network Service Mesh that yielded this board that we co-authored. But what you're watching now is the recap, the juicy learnings from the time that Ed and I shared. So here goes nothing. Ed, what was the world like before Network Service Mesh existed that caused it to need to be created?
So a long time ago, in a Kubernetes SIG networking far, far away, Kubernetes networking was sort of having a crisis of success in the sense that it had done something that was somewhat new in the world, and it introduced a new simplified networking model that was much better aligned with what application developers actually wanted and needed. But it was one where every pod had an IP address, and every pod could talk to every other pod at layer 3, OSI layer 3, unless you explicitly had a network policy that said, please select by label and selector some pods to isolate, and please select by label and selector some other pods to allow to talk to the isolated pods. And then the last piece of the networking model was Kubernetes services, which solved in a simple way the service discovery and routing problem so that you could say, I would like to go connect to an abstract service, and Kubernetes would select a set of pods that would provide that for you based on labels and selectors and connect you to one of them.
Networking model was absolutely fantastic, and it really got the job done. You quoted something to me in the longer version about the median. Will you tell me?
I think this is a quote from Linus about optimized for the average use case. And this was something where, for Kubernetes, where the average use case looks like somebody developing a web app or a microservice, this was absolutely a brilliant way to go about doing networking. But Kubernetes had gotten to the point of success at this point where you had people with different needs coming in who wanted to run workloads on Kubernetes. One of the starkest examples of this was telecommunication providers who wanted to be able to run workloads on Kubernetes that processed packets. But there was no sane way to even talk about that in the Kubernetes networking model. And so people were trying to figure out what to do. And there was an attempt to sort of pull back towards a more classical networking model, which would have degraded experience for everyone. And at the same time, there was another exciting thing happening in the world of cloud native. And that was the emergence of
Service Mesh.
Exactly. So Linkerd had been around and doing his thing for a little while. Istio just arrived on the scene. And so Network Service Mesh sort of went rummaging through Service Mesh's pockets and stole a bunch of ideas and tried to bring them into the world of lower level networking. Sort of networking that happens at OSI level 3 with IP packets or OSI level 2 with Ethernet, although we'll mostly just talk about IP here.
Can you help me understand why someone who's not a telecommunications company would want to be able to do this?
It turns out that, number one, the entire world is not HTTP. There are lots of use cases that you run into where that is not the protocol of choice. So one of the ones we ran into fairly early is people who had some primary database and they wanted to have read replicas of the database per cluster. And you wanted to then be able to have them do whatever weird replication protocol was going on between them which wasn't necessarily well suited to application level service mesh. I'll use the word application service mesh for what everyone else knows as service mesh when I need to make it clear that we're not talking about network service mesh. And so that's one situation where you would wind up with people who cared about things like this. Another one is around interorganizational communications. It turns out to be easier to negotiate that in a world where you're working at lower, simpler levels because it gives you less to manage as you're moving along.
So cool. I hadn't ever considered or thought about a use case where like a car company might need to share a service with its part supplier and how two completely different companies might navigate how to share something like that where they both are big stakeholders in it. So that's fabulous.
Or even ecosystems of companies where it's not just the part supplier and the car manufacturer, it's a whole ecosystem of part suppliers.
So we have these use cases of what NSM can do, but like, how does it work and what is it doing exactly to help make this work?
Network service mesh, again, we went rummaging through service mesh's pockets. And so it helps to work by analogy to things that are more familiar in the classic sort of Kubernetes service world or service mesh world. So in a Kubernetes service world, if you want to go and connect to something that provides an abstract service to you, you have the service that is registered as a service in Kubernetes. And it's basically just an abstract concept of what you want to connect to. And in network service mesh, we have something similar we call a network service. Ta-da! So where a service in Kubernetes might be something that you connect to and you send an HTTP message and it does things with that HTTP message. Maybe it goes and talks to other services, or maybe it changes the database and then it sends you a response. In network service mesh, we have a network service, which is something that instead of processing HTTP messages, it processes extended IP packets, obviously the things you're interested in as an application developer living at higher layers, and it will provide the connectivity to the other things you should be able to talk to, no matter where they are, whether they're inside your cluster or not, any sort of security or observability that you need at that layer. And it provides that as a service to you for communicating at that lower payload level.
So that must be a building block then for network service mesh.
Right.
Yes?
So that's a conceptual building block. And then network service mesh technology, it allows you to register the FX services you want, just like you would put a service into Kubernetes that describes what they are, and you put those into the network service registry. It allows you to things that provide a network service to register themselves as network service endpoints so that network service mesh technology knows where to find them. And then when a workload comes up and says, hey, I would like to connect to 0 or more services, we will go and network service mesh technology will string the virtual wires between your workload and the things providing the network service. You can sort of conceptually think of it as if your workload is a little server and we're connecting cables between that server and different networking switches.
What was important for the network service mesh definition to me was that it's as granular as workloads, because when we talked about application service meshes, those are more like entire meshes, like entire systems connecting to each other, as opposed to workloads only connecting to each other. So that was an important thing that helped me understand network service mesh. And then this piece of independent where each workload is running. If we have a workload in one cloud and another cloud on-prem, it doesn't matter. So I think I'd like to hear A, about the user experience in your words, and then B, I would like for you to cover what differentiates network service mesh from application service meshes.
From a user experience point of view, users don't really want to care about networking. So don't even want to know the network is there unless something goes wrong, in which case they want to know everything. Because the network is often blamed for things, many of which are not its fault. And so from a user experience point of view, if I'm working in Kubernetes, my cluster is network service mesh enabled. To have my workload connect to a network service, I can just simply add a single annotation line that enumerates the network services I would like to be connected to my pod spec. And when my pod comes up, it will have the virtual wires that connect it to things providing all of those network services. And the right traffic for each network service will be sent across the right virtual wire in order to reach that. Exactly. So pure magic. This is, sort of part and parcel of the way you want network experiences to go in cloud native. And of course, the sort of next question is, okay, well, how do you set up network service mesh in your cluster? The answer is there's an easy kube control apply that will network service mesh enable your cluster. And then, if you are in fact deploying your network services and the network service endpoints that provide them as pod workloads, then it's very much like deploying any other application if you deploy a network service itself. Very simple, very cloud native in its approach.
And then the registry also is an easy way to connect the different workloads running in different places to the network service.
Anytime you have a service mesh, there's some registry where you register the services, the abstract things you're providing, and the endpoints, the things that provide them. You see this in Kubernetes, oddly enough, with the service and endpoints resources. Network service registry does the same thing for network services and network service endpoints. Most users will never actually have to interact with that because all the magic happens in the background from the annotations. But if you're if you wish to do something peculiar, that resource is available to you. Sort of abstracted, we do have a backing store that will run it with a Kubernetes API servers, the backing data store, so you can interact with it with kube control. But the fundamental is actually a gRPC API. So we've also had people write things that just back onto normal databases as well. And that uses all the normal spiffy and Spire goodness for workload authentication. And then for authorization, by default, we use OPA, Open Policy Agent, all the good things.
If it ain't broke, don't fix it.
Yeah, although those are loosely coupled to Network Service Mesh because we have a few people who are already broken who need to continue to hobble forward with their brokenness. And so that's doable if you must. You're very much you're much better off if you can just use Spiffy, Inspire, and OPA.
So then let's talk more about what differentiates Network Service Mesh from application service meshes, like what you want to use one versus the other, and also how they complement each other.
Most people know a service mesh, which I, for the purposes of differentiation, call application service mesh. Things like Istio and Linkerd and Kuma. Mostly those are going to be operating on layer 7 messages. That's the payload. So HTTP messages. You send an HTTP message, it gets picked up by the service mesh, it gets routed to wherever it's going to be serviced. Various mutations may happen where it's mucking about with mutual TLS, where it's mucking about with possibly putting in open telemetry tracing tagging or all kinds of other things, but that's all mostly operating at this L7 payload layer. Now, application service meshes will also do a little bit of stuff sometimes at layer 4, but it's sort of a second-class citizen in their world usually. Network service mesh generally operates at layer 3. So the payload that we're dealing with is an IP packet. So we're operating at a lower, simpler level, which has a variety of advantages. If you don't, for example, have payloads that are HTTP and operate well with layer 7 service meshes, you can use Network Service Mesh to provide the connectivity at a lower layer.
I actually have a question about the L3 versus L7. If I'm trying to communicate, maybe I want NSM because I want the granularity of being able to connect workloads only without connecting entire systems. But I do want to convey more complex information, like what I recognize as HTTP. What would I do in that case?
Well, so there's a difference between conveyance and bringing the kinds of services that application service mesh provides to let you do cute tricks with it. From a conveyance point of view, any protocol that you run at higher layers above L3 just works, right? So if I'm running on a network service and the IP packets are being passed, the payloads of those IP packets may be TCP packets. The TCP packets payloads may be pieces of the HTTP message. So all of that stuff continues to work as normal. But in addition, this is where you start moving towards the complementarity. You can run an L7 service mesh on top of a network service mesh. And this turns out to be simplifying if you're running an L7 service mesh, because now instead of having potentially multiple different domains that have overlapping IP spaces, and so you've got complicated L7 gateways that you have to manage, instead of having all that, you would have something that looks like a single, simple service mesh, as if you were running it at a single cluster, but it's running over a single flat layer 3 that's provided by Network Service Mesh. It just so happens that workloads are plugging in from different clusters and from on-prem and from VMs, but they're plugging in a layer down from the service mesh itself. So the service mesh doesn't have to reason about the complexity of where all the workloads are coming from, because as far as it can see, they're all coming into a common layer 3 domain. Following in the proud tradition of networking for the last 4 decades, we lie to it so it doesn't have to worry its pretty little head. The other thing that Network Service Mesh does is, in some sense, it's less greedy than Application Service Mesh. Well, and greediness may be too pejorative a term, but effectively, it is the case that, in most circumstances, if I have a workload like a pod, that it has access to exactly one service mesh. Application Service Mesh. And it is typical, and there are some exceptions to this, so I say typical instead of not always true, but it is typical that if I have a cluster, there is typically exactly one service mesh available in my cluster. And trying to have more than one in the cluster has complications and potential problems. With Network Service Mesh, a given workload, a single workload, can connect to multiple mutually ignorant network services. They don't know anything about each other. And in fact, they might even be network services from entirely different organizations that don't know anything about each other. And because we do this at the granularity of the workload, we can actually work all of that out. One of the interesting side effects of this is because you can run an L7 service mesh on top of a network service mesh, and you can be connected to multiple network service meshes, you can in fact use network service mesh to allow your single workload to connect to multiple application service meshes at L7. And this gets to be useful if you have a workload that has to actually talk to different organizations or different companies, or even just situations where you don't want to have so much coordination or such large administrative blocks to deal with. If I have many clusters spanning many organizations and I try and shove them under a single service mesh, that gets very complicated very quickly. And the organic way that many companies grow, I've seen lots of large companies where they have different service mesh choices that have been made. This group is using Kuma, that group is using Linkerd, this group is using Istio. 5 other groups are using different instances of Istio.
As acquisitions get made too, like that's going to add to that kind of complexity. Absolutely.
There's this whole space that in networking we typically call extranet, which are it's not quite your network and it's not quite their network and it's not quite the public internet. It's sort of this weird in-between space. And often negotiating those things traditionally would be multiple quarters of deconflicting, overlapping IP spaces and firewall rules and all kinds of stuff. In network service mesh, it's a pure matter of authorization for a very narrowly scoped network service. And then workloads can connect to it in seconds.
The implication here is that it scales really well too.
It scales sort of at an internet scale. Normally, if you have a singular greedy thing and it gets bigger and bigger and bigger, the whole thing gets bigger and bigger and bigger. Network service mesh will let you have different network service registries in different domains that are completely independent of one another. And so the scale of things that you could access with network service mesh, if you were authorized, scales in the same way the internet scales. People can stand up their own DNS servers, have their own web servers. You can globally connect to them if you're authorized. Like if I try and go to your website and I'm not someone who has an account there and I'm not authorized, I may not get anything. Likewise, if I try and connect to a network service that I'm not authorized for, I wouldn't be able to connect to it.
So I think between us, we've covered everything on the board. Is there anything you'd like to say in conclusion about network service mesh or about joining the community or both?
You can find our website at networkservicemesh.io. We are a CNCF project, and we have a community tab right there at the top of the page, and that'll show you how we talk to each other over Slack and how to get plugged into that, where our community meetings are. They tend to be at both North America and Europe friendly times. It'll also give you a picture of the layout of our repos. We have actually a map of the multi-repos that we work on. It tends to be a very friendly and welcoming community. We're always delighted to have new people show up, particularly with new and interesting use cases, because a lot of the technology is about enabling you to do things that you wouldn't otherwise be able to do.
I'm so impressed with this technology, and I've really enjoyed you as a teacher throughout this process. Thank you so much, Ed, for sharing your time and expertise with us. And thank you, everyone who watched the video. I appreciate you all. Have a wonderful day.